Hello Math Analysis students. In this video we are going to learn to simplify basic trig identities, and we're going to simplify them to a single trig term or an exact value. So let's begin. Alright, first let's start off with our basic trig definitions. Now some of these we should already know. The basic definitions: the cosine of theta is x over our hypotenuse, or adjacent side over hypotenuse, which on our unit circle is just x, because in our unit circle the length of the hypotenuse, or the radius of our unit circle, is 1. So in the unit circle, cosine is just x, sine is just y. But of course our definitions are that cosine is the adjacent over the hypotenuse, and the sine is the opposite over the hypotenuse, or y over h. Our tangent is y over x, which simplifies to also sine over cosine. This is one that we are going to use a lot in our trig identities unit, that tangent is equivalent to sine over cosine. It's y over x. And also cotangent is equal to x over y, which is the reciprocal of sine, the reciprocal of tangent, which is cosine over sine. So we're going to definitely use those a lot. And also our reciprocal properties, which we have already learned about. And 1 over x is the notation for a reciprocal. That secant is the reciprocal of cosine, or 1 over cosine. Cosine could also be written as 1 over secant. Cosecant is the reciprocal of sine, or 1 over sine. And sine is 1 over cosecant. They're reciprocals of each other. And cotangent can also be written as 1 over tangent, and tangent can be written as 1 over cotangent. These ones here on the bottom, we're not going to be using those as often. Mostly we will be using our secant, cosecant, and cotangent, using those reciprocals. Now notice that cotangent, we said before that tangent was y over x, sine over cosine, and cotangent is cosine over sine. Still true, but also we have another identity that we can use, that cotangent is equal to 1 over tangent. Okay. So let's take a look at a few examples right here, like the sine of 80 degrees times the cosecant of 80 degrees. Well, the sine of 80, hang on just a second here. There we go. The sine of 80, we don't have to know exactly what that is, but since these are both 80, the cosecant is 1 over the sine of 80. And so if we multiply sine of 80 over 1 times 1 over sine of 80, then when we multiply, these cancel out, and we're left with just a value of 1. Nice. The cotangent times the secant. Well, cotangent, there's a couple ways we could do this, but we're usually going to try to simplify things to get them in terms of sine and cosine. So cotangent can be written as the cosine of x over the sine of x times, the secant of x is 1 over the cosine of x. And when we cancel here, then we have 1 over the sine of x, which we can simplify a little bit further. 1 over the sine is the reciprocal of sine, is cosecant of x. And down here we have the tangent of 40 minus the sine of 40 over the cosine of 40. So the tangent of 40, there's a couple ways we could do this one. But I'm actually going to go with, let's keep tangent of 40 like it is. And right here, let's change sine of 40 over cosine of 40. Let's change this to tangent of 40. Then we have the tangent of 40 minus the tangent of 40 equals 0. Now these work because these are all the same degree measure here. Obviously if they were different degree measures, then they wouldn't work. We could have also done this by changing this tangent to a sine over cosine, and either way we would end up getting a value of 0. Okay, now let's talk about some even and odd properties. And these have to do with respect to our graphs. Even properties refers to our y-axis symmetry. Take a look at the graph of cosine. We can see that it has y-axis symmetry, meaning that on the right-hand side and the left-hand side, there are reflections, they are mirror images of each other. And the cosine of negative x is the same thing as the cosine of positive x. And we can see that here with some of our values that we know from the unit circle. The cosine of pi over 6 is root 3 over 2. The cosine of negative pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Cosine of negative pi over 4 is root 2 over 2. Cosine of pi over 2 is 0, and cosine of negative pi over 2 is 0. Now these are ones that we can evaluate because we know them on the unit circle, but it might be helpful for us sometimes if we have cosine of negative x right here, or something that we don't know the value of, to recognize that the cosine of negative x is the same thing as the cosine of x. And if we can get rid of a negative sign there with something that's equivalent, that's going to make things simpler for us. And then our odd properties or when something has origin symmetry. You see here that this is not symmetric around the y-axis in the same way that cosine was. This is our graph of sine, and so when we compare values for the sine of x and the sine of negative x, like over here the sine of pi over 6 is 1/2, the sine of negative pi over 6 is negative 1/2. Same thing with the pi over 4, negative pi over 4, and pi over 2, negative pi over 2. What we come up with is that the sine of negative x is equivalent to the negative, or the opposite of, the sine of x. And that holds true for tangent as well, because tangent has origin symmetry. Alright, so how does that help us? Well, if we want to simplify some basic trig identities, we can do those in a couple of different ways. The cosine of negative 30, because it is even and has y-axis symmetry, that is equivalent to the cosine of 30. And of course we know that the cosine of 30, which is the same thing as the cosine of pi over 6, is root 3 over 2. Of course, since this is a unit circle value, we could also just determine the cosine of negative 30. Fourth quadrant angle would still be root 3 over 2. The sine of negative 60, sine has origin symmetry. It's an odd property, and so the sine of negative 60 is equivalent to the opposite of, or the negative, the sine of 60. And of course the sine of 60 is root 3 over 2, so this would be negative root 3 over 2. And we can of course verify that by calculating the sine of negative 60 degrees, which would be in the fourth quadrant, which would be a negative amount. And the cosecant of negative 45, cosecant being the reciprocal of sine, same properties as sine up here. This would be equivalent to negative cosecant of 45, which is the same as negative cosecant of pi over 4, which gives us negative square root of 2. Okay, now let's talk about cofunction properties. Now these look a little bit intimidating, but they're not really saying anything scary. The sine of pi over 2 minus x is equal to the cosine of x. And the cosine of pi over 2 minus x is equal to the sine of x. And really what this is saying is just that our x and pi over 2 minus x are two angles that are complementary. They add up to 90 degrees. And so the cosine of one is equal to the sine of the other. And we know this already with a couple of things on our unit circle. We know about pi over 3 and pi over 6, which are 30 and 60, that add up to 90 degrees, that the sine of one is equal to the cosine of the other. Also works with 45 and 45. And over here, the sine of x is equal to the cosine of pi over 2 minus x. And it looks a little intimidating with this whole pi over 2 minus x and x, but again, it's really just talking about two angles that are complementary. They add up to 90 degrees or to pi over 2. And the same thing with tangent. The tangent and the cotangent of complementary angles are equal. That also works with our reciprocal functions, that the cosine and the secant of complementary angles are equal. Excuse me, I think I just said cosine and secant. I didn't mean to say that. I meant to say cosecant and secant. My apologies there. Secant and cosecant of two complementary angles are equal. So sine and cosine of complementary angles are equal. Tangent and cotangent of complementary angles are equal. And secant and cosecant of complementary angles are equal. Okay, so let's simplify a few things here. Now for this one, we have the cosine of pi over 2 minus x over the sine of pi over 2 minus x. And we could do this in a couple of different ways. But if we have the cosine of pi over 2 minus x, that is equal to the sine of x And the sine of pi over 2 minus x is equal to the cosine of x. And the sine over the cosine is equal to the tangent of x. Now another example, the cosine of pi over 2 minus x times the cosecant of x. Well, we know cosecant is the reciprocal of sine, so let's change this to sine. The cosine of pi over 2 minus x is equal to the sine of x times the cosecant of x is equal to 1 over the sine of x. And the sine and the cosecant are reciprocals of each other. These things cancel out, and we're left with just 1. And down here, the cosine of 10 and the sine of 80. There's a couple of different ways we could do this. We could rewrite this. The cosine of 10 is equivalent to the sine of 80, because 10 and 80 are complementary. Then we have sine of 80 over sine of 80, which of course equals 1. We could also have chosen to rewrite the bottom if we wanted to. We could have left this as cosine of 10. And right here for sine of 80, that's equivalent to the cosine of 10, because 80 and 10 are complementary. And then once again, the cosine of 10 over the cosine of 10, that simplifies to be 1. So whichever way we choose to do that one, we're still going to get a simplified answer of 1. All right, now we're going to talk about our Pythagorean identities, and we are going to use these a lot this unit. So you definitely want to get yourself familiar with these. First off, we have sine squared theta plus cosine squared theta equals 1. And we already know that from working with our unit circle, that the sine squared theta is equal to y squared plus the cosine squared, which is x squared, and y squared plus x squared equals 1 is just a version of the Pythagorean theorem, which says a squared plus b squared equals c squared. And this one is like super important for us. You definitely want to learn this one. Sine squared theta plus cosine squared theta equals 1. There's also two others that follow from that. We have tangent squared of theta plus 1 equals secant squared of theta. And we have 1 plus cotangent squared theta equals cosecant squared theta. Now, these two sometimes can be a little bit hard to memorize, but if you can remember this first one right here, I'm going to show you how you can derive those others. Sine squared plus cosine squared equals 1. So let's talk about deriving that for a second. If we take our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. We're going to actually do this in two different ways. So I'm going to write it twice. If we divide everything here through by cosine squared theta, let's see what happens. We divide this term by cosine squared theta, and this one, dividing everything through by the same thing. Then we have sine squared over cosine squared becomes tangent squared theta. Cosine squared plus cosine squared over cosine squared, something divided by itself is 1, equals, and 1 over cosine squared theta is secant squared theta. Which is, going back, it's just that second identity right there. Tangent squared theta plus 1 equals secant squared theta. And so this time we divided by cosine squared. What if we divide by sine squared instead? So let's see what happens there. If we divide this term by sine squared, and this term by sine squared, and this term by sine squared, and that should be an equals, not a... Hang on a second. Let me just fix that. Oops. Sorry about that. Okay, let's try one more time here. Okay, that was supposed to say equals 1. So if we divide by sine squared theta, then sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared theta. And 1 over sine squared is cosecant squared theta, which, going back, is just that 1 plus cotangent squared equals cosecant squared. So if you can remember sine squared plus cosine squared equals 1, then you can derive these others anytime you need to. Now from there, of course, there's a couple of variations just want to talk about really quickly that we will be using also. Sine squared plus cosine squared equals 1. We could also write this in a couple of different ways if we wanted to. We could subtract the cosine squared, and we could write sine squared theta equals, if we subtract cosine squared from both sides, we have 1 minus cosine squared theta. We could also choose to subtract the sine squared, and we would have cosine squared theta equals 1 minus sine squared theta. And we could do the same thing with our others. Our second identity was tangent squared theta plus 1 equals secant squared theta. So we could subtract 1, and we could have tangent squared theta equals secant squared theta minus 1. Or we could have 1 equals secant squared theta minus tangent squared theta. And these are all just variations. They're all equivalent to each other. And we could do the same thing with our last identity, which is 1 plus cotangent squared theta equals cosecant squared theta. We could write this as 1 equals cosecant squared theta minus cotangent squared theta. Or we could write cotangent squared theta equals cosecant squared theta minus 1. Pretty much anytime we see two of our trig functions, if we see them squared and a 1 in any combination here, we're going to think, yeah, let's check out and see if it's a Pythagorean identity. So let's try a few more examples together. What if we have 1 over 1 plus cotangent squared theta? Well, 1 plus cotangent squared theta, that's one of those Pythagorean identities that we just learned about. That is equivalent to cosecant squared theta. So we could write this instead as 1 over cosecant squared theta. And then, oh, there's a reciprocal function right there. 1 over cosecant squared is simplified to just sine squared theta. What about sine squared of 20 degrees plus 1 over secant squared of 20 degrees? Since they're both 20 degrees, then we can go ahead and work with those numbers. We've got sine squared of 20 degrees plus 1 over secant squared. That's a reciprocal function. This is cosine squared of 20 degrees. And the sine squared plus cosine squared, since they're the same degree, equals 1. One more here, cosecant squared of 42 minus 1. This looks like one of those that we just talked about over here, the cosecant squared minus 1, which is equal to the cotangent squared. So that would be cotangent squared of 42 degrees. And just a few more. Let's find the exact value here. Since these are both 58 degrees, then these would be the same thing as just x. Secant squared of x or theta minus tangent squared of that same number is just going to equal 1. Sine of 68 times cosecant of 68. Again, these are reciprocal functions, so this is sine of 68. Cosecant is 1 over the sine of 68. These things cancel, and we just have 1. And for our last one here, tangent of 70 minus cotangent of 20. Well, 70 and 20, they're not the same number, but they are complementary angles. So the tangent of 70, and well, this cotangent of 20 is the same thing as the tangent of 70. And if we subtract tangent 70 minus tangent 70, we get 0. We could also have changed this tangent of 70 to a cotangent of 20. Would have gotten the same result in the end of 0. All right, things to look for. Change reciprocals or quotients. Change to reciprocals or quotient identities. We usually want to get things simplified if we can. We want to put things in terms of sine and cosine whenever possible. If we see any trig terms squared and a 1, try a Pythagorean identity. And we might have to use some algebra and some arithmetic skills to add, subtract, multiply, divide, factor, all kinds of stuff. Next lesson we'll be learning more about some of those specifically, but let's do just a few more right now together. I encourage you to try these on your own. I encourage you to pause the video, give them a try, and then see if you get the same things. Alright, so the tangent of x, this is the same thing as the sine of x over the cosine of x. And the cosecant is the same thing as the 1 over the sine. So our sines cancel, then we have 1 over cosine. 1 over cosine is equivalent to secant of x. How about 1 minus cosine squared times cosecant? Well, 1 minus cosine squared, that is the same thing as sine squared of theta. And cosecant is 1 over sine of theta. Now this time they don't quite cancel out because we have up here in this numerator we have sine squared, and here we have sine. But sine squared is like sine times sine. So this sine cancels with one of these, and we're left with just sine theta. How about the cosine of negative x times the cosecant of x? Oh, okay, so cosine of negative x, we learned before, that's the same thing. It's just the cosine of x. And the cosecant is 1 over the sine of x. So we have cosine over sine, which is cotangent of x. Secant squared theta minus 1 over tangent squared theta. Well, secant squared theta minus 1 is a variation on a Pythagorean identity, and that simplifies to tangent squared theta. And of course, tangent squared theta in the top and tangent squared theta in the bottom is going to give us a value of just 1. And our last one down here, let's see, this says, it's a little hard to see, I apologize for that. It is sorry about that, it says the cosine of negative x times the secant of x. Well, the cosine of negative x is equivalent to the cosine of x. And the secant of x is 1 over the cosine of x. And cosine times its reciprocal simplifies to be just 1. And our last one here, we have 1 over cosecant squared x minus 1. Variation on our Pythagorean identity, that's equal to cotangent squared. And 1 over cotangent squared, that's the reciprocal of cotangent squared, which is just tangent squared. And I accidentally changed it to a theta when I should have put an x. Sorry about that. And so our answer would be tangent squared of x. And so we are going to be using these a lot during this unit, so you definitely want to familiarize yourself with all of these basic trig identities. We're going to learn about how to apply them in even more ways in the future. All right, that's it.